All right. So we've looked at straight bars. We have tackled items 1, 2, 3, and 4 on here. Okay? What's left really is the denominator in this sort of the back end of this equation. And this denominator looks like this. All right? The one thing that I want you to write down underneath all the code stuff here is this denominator is never taken as larger than 2.5. So write that down on your piece of paper. That denominator of this formula, once you get done calculating it, never is more than 1.5 or 2.5. Excuse me. It can calculate out to be larger, but if it is larger, you use 2.5. It can calculate out to be 4.2. But if it does, you use 2. You just replace the whole thing with 2.5. All right? So this denominator is handled a little bit differently in the fact that you are going to calculate it, but when you do calculate it out, it's you always check and say, hey, is it greater than 2.5? And if it is, then you adjust it. All right? Okay. Start with the easy one, dB. What's dB? Diameter of the bar. That's an easy one. We know all about that. All right? Let's talk about these two things up here. CB. CB is actually written down on your sheet. Okay? It's number 5 down there. I hate the name of what they give this because it's misleading. But on your sheet, CB is called the spacing or cover dimension. All right? That's misleading. But you can read. And what I expect you to do is read what it says after that. It says use the smaller of either the distance from the center of the bar or wire to the nearest concrete surface or 1/2 the center to center spacing of the bars. I'm going to do you one better. I'm going to draw you a picture. Here's a beam. Okay? It's got, and we'll make it easy, 2 bars in it. All right? First thing it says use the smaller of. It's going to give you 2 things. Use the smaller of these 2 things. The first thing it says is use the smaller of the distance from the center of the bar out to the nearest concrete surface. So that could be this way, or it could be down, or up, or wherever. But the center of the bar to the nearest concrete surface. Let's call that distance A. All right? Then it says, or 1/2 the center to center distance between bars. Center is we call the spacing typically. Okay? Let's use that. I'll call that B. I even do this for all the people that'll see this one day on YouTube. Say, look at that. A and B. Man, that's nice, isn't it? That is just great. All right. Yeah, think about this. You people, well, not you, but your colleagues in the summer will get to see this on free. Someday this will be in Redbox. This will be other places. So anyway, A and B, you calculate them out. You choose the smaller. All right. I don't like the name of it because they said cover and spacing, and it really ain't cover. It's something associated with cover, but it goes to the center of the bar. And spacing, you don't really think about that because they say it's 1/2 the center to center spacing. So it's whatever. But A and B, choose the smaller of it. All right. That's what CB is. Now we move on to KTR. KTR is a factor that has to do with transverse reinforcement. That's the T, transverse, R, reinforcement. Okay? For us, basically, they're talking about stirrups. Okay? Or ties. Here's the deal with KTR. You can take it as being 0, and you're conservative. So a lot of people just say, KTR is 0, I'm not even going to worry about it. Okay? You might have a problem in the book that says, do this problem. Oh, by the way, KTR is 0. Okay? Fine, do it. KTR is 0. There, that's easy. All right? KTR could have a formula. So you might get an example, and an example might say, we're doing it both ways. We'll do it conservative with KTR is equal to 0. We'll do the calculation of KTR. Calculation of KTR is fairly simple. If they do make you calculate it, it's a formula that says this, 40, and this, I'm looking at the book on page 166, but I think it's actually before that. But they got a formula that says 40 ATR divided by SN. If they do make it calculated 40, hey, no big deal. ATR, for us, if we're dealing with stirrups, which most of the time we would, this would be like the same as AV. Okay? Area of transverse reinforcement. This is like, for stirrups, this would be AV. And that's what transverse reinforcement would be for us, would be stirrups most of the time. I mean, it could be ties, but that would be like AV. Okay? S would be the spacing, again, of the stirrups, if we're using those. So spacing of the stirrups. Okay? N would be the number of bars being developed. Okay? So like if I was talking about a beam, that had some stirrups around these bars, these 2 bars, the number of bars that I'm showing that have to be developed will be 2. So N is the number of the bars, not the bar number of bars. Okay? And S is the spacing of the stirrups. So ATR would be like, if this was stirrups, we would call this AV. S would be the spacing of the transverse steel, so that would be like spacing stirrups. N would be the number of bars being developed. Okay? So, and I think they actually do an example here or there where, they say they're going to use